So we are beginning our new unit tonight on ratios, rates, proportions, and we will move from there into percents. So let's get started. In your packet, the first thing we're going to talk about is ratios, rates, and unit rates. So a ratio is a comparison of two numbers by division. Examples of ratios are seen below, and that is three different ways of writing a ratio. You can use the colon, you can use the word TO too, or you can use a fraction. Now they are always read the same, however, and that is 2 to 3. So even with the colon or the fraction, you don't, when you're talking about a ratio, you don't read this as 2/3. You read that as 2 to 3, the same way. Since ratios are a type of fraction, we always express them in simplest form. That means you have to reduce it. So 15 to 40 would be reduced, and you would get, 3 to 8. Okay? So write each of the following in simplest form. You can go ahead and pause here and do that on your own. If you're back with me, for 16 to 48, I got 1 to 3. 35 to 25 is 7 to 5. 48 to 12 is the same as 4 to 1. Compare finding a ratio equivalent to 12 over 21 with lower terms and equivalent to 12 over 21 with greater terms. So that's just saying, give me an equivalent ratio to 12 21st that's in lower terms, so we could divide each of those by 3 and we would get 4/7, or likewise we could multiply, say, each of those by 3 and I would get 36, and if I multiply that by 3 I get 63. And so we could reduce those also, and you would always come back to the simplest form, which is 4/7 or 4 to 7. Now, one of the big areas of concentration for New York State is to incorporate fractions into each of our units. So that is part of the new core curriculum. They want us to really focus on implementing fractions. So we're going to start with a basic ratio in simplest form, 2/3 to 8. Now if you think about that, remember that's a fraction. It's a complex fraction, 2/3 to 8. And remember that a fraction is basically a division bar, so that means 2/3 divided by 8, which is keep, change, flip, 2/3 times, that's 8 over 1, so it's 1 over 8, and then I can cancel, and my final answer for this would be 1 to 12. Now in the second case, you could go ahead and try that on your own, and if you simplify that, you should get 4 to 5. And in the case of 1/7 to 3/5, you should get 5 to 21. So hopefully you did okay with those. It's just division of fractions, so if you're struggling a little bit there, you got to go back and review that. All right, now when we're talking about things with units, we have to make sure that units are the same. That is a key element for a ratio. It is a comparison of two numbers by division in which all units are the same. So I can't make the comparison 4 inches to 2 feet. I have to convert this 2 feet into inches. Okay, 12 inches in a foot, so that would be 24 inches, and then I have to go ahead and I have to simplify that to 1 to 6. Does it matter if we change feet to inches or inches to feet? Which is preferable and why? I would like you guys to think about this as a hot question for tomorrow. This I would like you to answer on your own and bring in your thoughts to me. And again, you can pause here and take care of the next section. We first need to convert to the same unit, and then we need to reduce. Go ahead, pause, and try it out. 3 days is 72 hours, so that's 4 to 72, and if I reduce that, I get 1 to 18. 45 minutes to 1 hour, well, 45 minutes to 60 minutes is the same as 3 to 4. and 2 pounds to 12 ounces. There are 16 ounces in a pound, so that's going to be 32 ounces to 12 ounces, and then if I reduce that, it's 8 to 3. Now we can also express ratios as decimals, and you see that typically in sports. Jack made 10 out of 16 foul shots. That could be expressed as 5 to 8, or he made .625 or 62.5% of his shots. Batting averages also are types of ratios. Hits to total at bats. And if you had this, 8 over 25, you would be in the Hall of Fame. A rate is a comparison of two numbers in which the units are different. So these can't be converted to one another. I can't convert if I have 6 cans of Pepsi for $2.59. I can't convert dollars to cans or cans to dollars. There's no conversion for that. Okay, and the unit rate is in fact rate per one. Okay, this is per one. And they're also expressed in simplest form where the denominator is always 1. So it may be a fractional thing. So 6 cans of Pepsi for $2.59 expressed as a unit rate. What you have to do here is it's $2.59 for 6 cans. So you have to go ahead and do the division. And then you would figure it out for money, which is 2 decimal places, so I divide out to the 3rd decimal place to make sure I don't have to round up. And the rate is 43 cents per 1 can. Okay, so a unit rate is per 1. Our common unit rates that you will see are miles per hour, miles per gallon, kilometers per hour, words per minute, etc. So go ahead, take some time here, pause again, and express each of the following 1 through 4 as a unit rate. So 120 miles in 3 hours is the same as 40 miles per hour. $1.68 for 12 muffins would be 14 cents per muffin. And you can use that slash, that means per, in math and science. $58.50 for 30 gallons is going to be $1.95 per gallon. I wish that might have been gasoline. And 290 words in 5 minutes is going to give me 58 words per minute. Now, be careful about this. This is a very common mistake that students make. If I'm talking about 9 cents, there's only one correct answer there. This is the correct answer. The other one is $0.0009, which is not even anything we want to think about in terms of money. So be sure to be careful with that. I think you'll know what I mean when you look at that. Unit pricing, again, if you go to Wegmans, Target, any place, usually up on the shelf, they have the unit pricing. So you might see something if this is the shelf, and they have like $2.79 for a bag of Lay's potato chips, okay? And next to it, they'll have this little thing, and it'll say 0.294. And they'll tell you what the units are. It might say ounces. It won't say chips. You don't pay per chip. But and then you could compare it to the Wegmans brand. So unit pricing is very important. I always pay attention to unit pricing when I'm out shopping to find the better bargain. So compare the following and identify the better buy. So when you're asked to find the better buy, they're really looking for this unit pricing, and it's basically a division problem. Okay, so this is saying $4.79 for 18 ounces. So you have to kind of go over to the side and divide $4.79 by 18, and then $3.50 is this one, $3.50 for 12 ounces. So you kind of got to go over to the side and divide $3.50 by 12. And then you're going to compare the answers that you get. Go ahead, you can do that math on your own. Pause me. In the case of the Super Sugar Smacks, I got 0.2661 with the 1 repeating. In the case of the Sugar Star Bites, I got 0.2916 with the 6 repeating. So the better bargain is obviously going to be my Super Sugar Smacks. That's my better bargain. How about a 10-pack of pencils for $1.59 or an 8-pack of pencils for $1.09? Well, Okay, I got that the 8-pack was the better buy because these were 0.136 per pencil. And this was 0.159 per pencil. And so that is unit pricing. What I would like you to do now is take a look at the problems on the next page. I would like you to do these, ramp it up on your own. This will finish out the night, and we'll talk about this first thing tomorrow along with this question I wanted you to do on the notes page. So have a great night, and I'll see you tomorrow.